Hi, good morning. Today I'll be talking about three-phase systems. So, this is basically the most common type of your polyphase systems. The idea of a polyphase system or a three-phase system is that, okay. For single-phase systems, single-phase muna tayo. You can represent a single-phase system as a source delivering power to a load such that you have this line para dumaan yung current going to the load from the source to the load, and then you have a return path that is going back to the source. That is basically your single-phase systems. Okay, such that what you have is this voltage here, isang voltahe dyan between your wire going to the delivering power from the source to the load, and then your wire returning that power from the load to the source. Okay, so that's your single phase systems. Now the difference of polyphase systems, or in this case let's be more specific into three phase systems, is that this one. If you have this source and it is delivering, if you have this three-phase source and it is delivering power to this three-phase load, there is hindi siya dalawang line lang, such that you have one line for power going into the load and then another line as the return path. What you have is three lines for three different phases. So you have what we call phase A, what we call phase B, and then what we call phase C. In some cases you have a fourth line, and that fourth line is your ground or neutral. So for cases na meron kang four lines, basically what happens here is your source is delivering power to the load through lines A, B, and C, and then the return path would be yung ating ground or yung ating neutral. So you have these powers going here, going there, and then this is going here. Okay, now on you call this, on some cases naman you only have three lines, so wala kang ground. So what you have is just your source and then your load, and then you just have line A, B, and C, and then each line may act as a return path for the other lines. Or what's actually quite difficult for polyphase systems is that your understanding of vector operations, your vector addition particularly, is very very crucial, kasi when you have a single phase system, medyo madali yung ating vector operations, because you're just considering one phase, single phase lang kasi siya. But for polyphase systems, medyo mas complicated yung ating it's a little bit more complicated. The vectors are a little bit more complicated because you're considering not just one phase but three phases. Of course, if you have other polyphase systems that are greater than three phase systems, that's possible. I think there are systems that utilizes 6 phases, but yeah, well, essentially it can be reduced into 3 phases. But well, anyways, then it becomes more complicated because you're dealing with not just one phase but many phases. So mas marami kang vector angles na kino-consider. Okay, I think one reason din kung bakit complicated ang solutions dito is because when you have single phase system, if you are delivering 10 amperes here, then you are getting the same 10 amperes there pabalik. Okay, but for polyphase systems you have S and load. If this is delivering 10, 10, and 10, if you have a return path na ground, pwedeng walang bumabalik dyan na 0. Pwedeng bumabalik dyan na 0 lang. Okay, so if you're delivering this 10 here, delivering another 10 here, delivering another 10 here, there is a possibility that you are not returning 30 to the source, but you are returning 0. Okay, there is I don't know if it's possible, but probably pwedeng ang binabalik mo lang is 15 or whatever. Yeah. Okay, so that's the complexity of three-phase systems. You have to be more aware that what you're dealing with are vectors. Okay, so yeah. So how do we generate three-phase power? Hindi naman siya ganun ka komplikado. It's not really new. If you're not familiar with generating AC power on single phase systems, then I suggest you go back to a previous video. I think I have one for EE50 on rotating DC machines, induction of voltage. So the idea on EE51, the idea on EE51 is that you have an induced voltage on one coil. So let's say this is that coil. Okay, so for three-phase systems, it's basically the same principle, but instead of generating only one coil, you generate on 3 coils for different phases. So you have one coil for phase A, one coil for phase B, and one coil for phase C, and all of them are independent from each other. So yeah, all of them are independent from each other, and then you just separate the windings by 120 electrical degrees, and then now you have a three-phase power, three-phase voltage. So yeah, basically yan. That's your three-phase power. All of them are sinusoidal. Yeah. Okay. Sige. Now, on three-phase systems, we have this, what we call phase sequence. So this is not present in single-phase systems kasi you only have one phase for single-phase systems. But for three-phase systems, you have this phase sequence. And by convention, we call phase sequence as ABC or ACB sequence, or positive sequence for ABC and negative sequence for ACB. So what does it mean? By looking at the vectors, if you have a coil that is producing this voltage, and you call that coil 1, and then you have a second coil that you call coil 2 that is producing this voltage, and you have a third coil that you call coil 3 that is producing this voltage, then it is ABC sequence or 1, 2, 3 sequence if after 120 degrees from the peak of 1 you get the peak of 2, that is 120 degrees, such that kaya nating sabihin such that we can say that coil 1 is leading coil 2 by 120 degrees. Nauna siya by 120 degrees. And then coil 2 is leading coil 3 by 120 degrees, such that we can say that coil 1 is leading coil 3 by 240 degrees. And then take note, this is a cycle and it is an infinite cycle as long as nag-generate ka ng voltage. Coil 3 is leading coil 1 by 120 degrees. And then and so on and so forth, the cycle goes on. So what you actually have is 1, 2, 3, and then 1, and then 2. So sometimes it's called 1, 2, 3 sequence, or 2, 3, 1 sequence, or 3, 2, 1, 3, 1, 2 sequence, or A, B, C, A, B. So sometimes it's called ABC sequence, or BCA sequence, or CAB sequence. Pero the most common is ABC because most of the time, almost always, we use phase A as the reference. So A first, then B, and then C. Or 1 first, then 2, and then 3. Now, that's your positive sequence. Another type of sequence is when, again, I'll be using 1 as reference. So when you start with 1, the next coil is not coil 2 but coil 3. And then after 3, you get coil 2. So what you actually have is 1, 3, 2. And then 1 again, and then 3. So it's 1, 3, 2, 1, 3. Or A for 1, C for 3, and then B. So it's ACB, AC. So it's sometimes called ACB or CBA or BAC sequence. So that's negative sequence naman. So that's basically the difference of ABC and CBA sequence. So in this scenario, I think what happens here is you are generating A first, and then after 120 degrees, nag-pick C, B. And then after another 180 degrees, nag-pick C, C. So that's ABC sequence. Okay. One way to generate negative sequence is pagpalitin mo yung coil ni B at saka ni C. Lagay mo dito si C, lagay mo dito si B, lagay mo dito si B, lagay mo dito si C. Then you now have an ACB sequence. Okay? Yeah. Let's see. So in vector representation, these are your vectors. This is for positive sequence. Basically what happens here is if you start at A leads B by 120 degrees. Then B leads C by 120 degrees. So that is ABC sequence. Now, una si A, and then si B, and then si C. You go from this way to this way. Okay? Now, for negative sequence, you have A as reference, and then it leads C by 120 degrees, and C leads B by 120 degrees. Going this way. Okay? Another way to look at it is that A lags. Nahuhuli. A lags B. Nahuhuli si A kay B by 120 degrees. But yeah, it's basically the same as B leads A by 120 degrees. Okay. So yeah, that's basically your vector and vector representation for three-phase systems.